Welcome, everyone. Welcome to this session of Data Engineering Process Fundamentals. Today, we are talking about building a cloud-based data pipeline from raw data, from a concept, all the way to visualization. So we'll go through a journey where we actually talk about the steps, the process, and why are we doing those particular steps. So if you ever thought about, hey, I have a data project, I need to process data. I need to visualize that. I need to create a data pipeline, right? This presentation will enable us to basically understand this process and what steps to take to process that information and execute this project successfully. So welcome to this presentation. My name is Oscar Garcia. I'm a principal engineer. So I play with data engineering, software engineering, just like you guys. So welcome to this presentation and thank you. To start with, let's introduce this concept, right? What is data engineering? What is it, right? It's really a process that follows and executes a series of steps or phases, right? That enables us to understand a problem statement. What are we trying to achieve, right? Identify the scope of work, figure out the design, the architecture that's going to help us get this going, right? So through this journey today, we're going to talk about the discovery process, design and planning, data pipeline and orchestration, data modeling, data warehouse, and data analysis, and ultimately visualization. And don't worry if you feel like I'm going too fast. There's tons of material here on GitHub. All the code repos are there. All the information for you to execute the steps, install dependencies, and read and get background on this. And we're recording this video as well, so you can go back to it. But if you follow that project on GitHub, follow it, please join us because this continues to grow. This is that GitHub project is also where the code samples for this book that you see in front of you are located, and we continue to grow it, right? We have data streaming and other things that we are adding to that project. So please follow that, give it a start, and thank you. All right, so let's start with phase one, the discovery process, right? The discovery process is really involves identifying the problem, analyzing the data sources, and defining project requirements. So we can come up with a project scope and understand what we're trying to do. Also try to figure out, okay, if we're doing this, what kind of design and architecture do we need, right? So we need to understand the background. What is that data that we need to process? Where does it come from, right? What is the problem statement? What are we trying to achieve? What are we building, right? So we go through a series of steps like EDA, exploratory data analysis, to actually look at the data, make observations using tools in programming languages like Python. After we do the analysis, we define our requirements. We identify the scope of work and set the stage for the project, which is really, now that we understand what we're trying to do, we need to identify what programming language, what tooling, what cloud data platform that we need to use, and so on. And definitely come up with a design and architecture to build this. First of all, so it makes sense to you, let's learn the background of what we're trying to achieve, because this will be like a hands-on process that we're trying to do. The background of this conversation today is the MTA, which is the subway system in New York. And what they do there, every time you go to the subway, you go and exit the subway, you go through these gates, right? So they're tracking every single person that goes through this gate, right? And that is millions of people a day that go through this gate, right? So this is a big data issue that we need to kind of tackle and figure out, right? So all these gates are equipped with tracking. They record what station, what gate, in or out, right? If they're coming in or they're leaving the station, right? And what they do is they have a set of CSV files that they process and they make that available to us. So to any person that wants to create some kind of analysis based on that information. So it's important. So here we need to identify that there is the process here. It's not an API, but it's a CSV file. That starts signaling what we need to do. We need to identify that this probably is a batch-oriented process, right? So that's how we start building out this information, right? If it was an API, we go into data streaming perhaps, and so on, right? Data streaming is not in the scope of this conversation, but the GitHub people has that information as well. So the problem statement really is that in the city of New York, right, tons of people, millions of people use the subway system, and businesses understand this. So what they want to be able to do is be able to use a geofencing technology, which enables us to, as we carry our phones, to understand where we are located. So right now we're located on this university. So now our phone is being tracked. Businesses want to be able to identify that when a person is near Times Square, what have you, target those people and send discounts, meal coupons, and whatever for people to come onto their business. So we need to create and identify geofencing. So a good way to do that is the subway system. The subway system is all over the place, and we can use that location of the subway system to see as people come in and they leave and they come in, right? So they want to be able to use that technology to do that. Okay, when you see my friendly friend there pop up with a magnifying glass, that means that's demo time. So let's go and work on that. So now we sort of understand the project statement, right? So we know the project statement, we know what we're trying to do. So let's take a look at this work. All right. So quickly, just to introduce to you the GitHub's project, right? It has the structure is it has a folder for every process, and all the code and all the information are located in the README file. So make a note of that, right? As you visit every folder, use the README file. It gives you all the dependencies, how to install it, how to run it, and how to understand what we're trying to do, right? So we know the problem statement. We know what we're trying to do. So the end goal is really to come up with something like this. And that's the end product. The end product is we want to be able to look at analytics and be able to understand the traffic at around certain stations, at around certain days, and around certain day times, right? Times slots, like 11 o'clock, 12 o'clock, 1 p.m., and so on. So this is what we're trying to do. So the first thing we do is, all right, let's go to discovery, right? In discovery, you'll see here notebook files, right? So we'll try to do this on Visual Studio, and also we'll show you through the help of GitHub how this works. But let's look at Visual Studio really quick. So with Visual Studio Code, we can actually connect to GitHub, right, and open those files. And we can go ahead and look at the discovery file, which is a Jupyter Notebook. Anybody familiar with Jupyter Notebooks, right? Just a way to kind of put, if you're not, I'm telling you, very powerful. If you're using a lot of SQL statements, start using something like this, very powerful to allow you to do data analysis, data discovery, right? And because you can just write a snippet of code to be able to understand what's going on. So the first thing is we download the file. I'm not going to download the file here because I don't want you guys to, but these are the steps, right? Download the file and do the EDA, right? Exploratory data analysis. And you can just run this, right? You can run every cell. You can do Control Enter or just click the play button. And this will just run, take a look at the data, analyze it, and give you information, right? So it tells you, and think about it, right? Right now, we're becoming familiar with this. We don't understand this data. It's the first time that we're looking at it, right? So we're kind of seeing that it has a bunch of columns. And we can see that day and time is separated, right? It's two different columns. We see some description, we see entries, we see exits. So here's where we're trying to make sense of what's going on. So, right, we're querying this information. We're using Python. If you're not familiar with Python, right, we're reading a CSV file. We're doing a data frame info here to be able to understand what is the data structure, right, the field names, the data types. And usually because it's a CSV, everything is object, which is a string. Right, so those are the things now that we're saying through our process. Hey, we don't want to deal with string all the time. We want to be able to come up with numbers, daytime, text, and so on. So this is part of that exploratory process where we're actually looking at this, right? So we need to clean up the data. We need to look at columns with special characters. We need to rename columns because maybe the columns are not the way we want them, right? We want to clean them up. We want to make them maybe small, lowercase. So with this, you can actually, by the way, is the font big enough? Can you see it? Okay. So with this code, you can actually go and start looking at special characters, for example. And we can say from this data frame, let's analyze what special character and maybe remove it because we just don't want that, right? Just remove the special characters, right? And then we can go through the process and then analyze what the special characters are and then clean them up. So for example, here, instead of having a C/A, we have a CA, right? And so we're kind of cleaning this up. We can probably make a small letter and so on. So we continue to learn and we start writing requirements or observations about what we're doing, right? We start looking for null values. Do we want to fill the null values with zeros, or do we want to drop that records, right? So we need to make those decisions. We may not want to drop the records because we may be losing some important information. So we just got to be careful and understand and commit to a process and a decision of how we're going to be doing that. So in this case, we just kind of query these and we say, look, there's nothing, everything is clean, there are no values. So this is important because as we write the data pipeline that we're going to build, these things that we're doing manually here are going to be executed through the pipeline, right? So you are actually collecting technical specifications on how to do through the pipeline. So this is key, right? It looks simple enough, but it's a fundamental step to be able to understand and hand down as a technical specification, right? So we can look at the data now. Let's analyze the data. What does it mean? What is CA? What is unit? What is the lineman name, and so on? So here we sort of understanding some of the data, right? We're looking at it. We're saying, okay, we have a day and time, and they're separated, right? So we have, maybe we don't want that. Maybe we want to join that because for our data warehouse, it's easier to handle day and time data values as opposed to split them in two. So those are the decisions, right? We know the measures, entries and exits. What do they mean? Entries, right? What does that mean? So as we do the analysis, we understand entries is really when somebody's coming into a subway station, and an exit is when someone's leaving the subway station, right? So this is how you go through the discovery process. And you do here, for example, we do the emerge a datetime into a new field called created, for example, right? And now we see that created field is one, right? It's a datetime field, which is really what your requirements probably want to do. So we're just really analyzing this and now looking at a structure. And now we kind of take a look and see that our data structure now is changing. Now we have an integer 64. We had that before, but now we have a datetime as opposed to an object, right? So now it's a valid datetime down to the nanosecond as opposed to a string, which is important for our analysis, right? And we can do some statistics, right? We can look at it, if it is applicable to your project, right? Depending if you're doing some kind of statistical analysis or depending, maybe it's just distributions, but these are the steps. This is the things we do. We kind of look at unique station. We're going through that brainstorming session and data analysis or looking at what is this data about, right? So we start writing observations, right? Entries, exits, stations provides a location. So we know that station name is really the geolocation point. That is how we're going to be able to target that geolocation, right? So we can start looking at it because we know the station is a geolocation point. Maybe that's how we need to start doing our aggregations, right? We need to start looking at it. What is the volume of people that are at a particular station at a particular time, right? So you start writing your aggregations. And this is key because this will eventually translate into your data visualization step, right? So these steps are important. This is really how you gather those requirements, right? And then you want to aggregate based on station. Is that meaningful? Is aggregating just based on station meaningful enough? Maybe not, because you need to target a particular date times. So at 3 o'clock in the afternoon, as opposed to just a station, right? So you need to know exactly at what time. So maybe that aggregation is not relevant, but it's part of that process, right? It's the exercise, right? And you can start looking at it. So if time is important, what are the times here? What are the unique times that we have? And we can see how they're recording this. And it appears that they're recording this every 4 hours, right? They're going for every 4-hour slot. So it's important. So now you can start playing with this, start looking at it with Python. It's there are powerful libraries like Plotly to generate visualizations, code-centric visualizations, and you can start doing some analysis about distributions, for example, right? And this starts giving you, okay, so I see this is how, this data, this is what this data looks like now, as opposed to just a CSV file, right? And then we know that we need to do some manipulation of the day. So perhaps we need to target Sunday, Monday, Tuesday. So we need to do some data manipulation. So this is basically starts going into a data modeling, right? Day, time, data modeling, which is a building foundation as well of the data warehouse. So we kind of see this, right? Right. And then we see that the numbers are humongous. And there's millions of people every day. These are humongous numbers. So maybe we need to start looking at it and projecting this data in trillions, billions, millions, right? What makes sense, right? We need to look at those numbers. So now here we're saying, okay, let's let's do a data analysis here and look at how this looks like. So we're looking at this data set. We're looking on a Sunday, you have 1.24 trillion people going through that station. That's massive amounts of data, right? So we kind of understanding the amount of data, the amount of traffic, and the data itself. And at the end of the day, this just gives us a time analysis that we can start looking at, doing these partitions, which are key also when we do our data modeling, right? And we start looking at the numbers and so on. So this is part of that process where we're charting and we're looking at it and we're understanding. And eventually we export this file because this file has already some building blocks about our data pipeline. And we can write them in a Python file that's actually now more code-wise. It actually does the analysis of how to run it, right? So for example, we can open this one, and if you're familiar with Python, we have an entry point, which is main. We receive parameters, and we execute this. And this file now, you can run it through the CLI, and what it will do, it will run it, download a file for a particular date time. So this is the format that you see here, where it says 230318. That's the format. So it's gonna build that, get that file, download it, process it, clean, whichever way it's gonna do, right? So you can take a look at this file, look at the main flow. This is another building block. So we start identifying flows. Flow is a key foundation of a data pipeline. Data pipeline, as you will see later, is built upon flows, right? Workflows, for example. So we start writing flows with the concept we need to download the file. We need to here download it, maybe stream it, right? So if you look at line 82, not download it in one chunk because the files are big, but download in chunks of 100 or 10 kilobytes or so, right? Why? Because we don't want connection timeouts on our pipeline, right? When we go and do an API call or a GET request or what have you, you want to be able to have the wire to be active. In chunks will do that. So it will do data streaming. It will prevent any kind of timeouts. So you can actually see this is a more mature code, right? So now we start building more mature code. We also, on top of that, we're compressing the file because CSV are too big. But if we compress that, we can eat up 75% of the size. Important for our data lake. Once we hit our data lake, because our data lake is going to contain this, and you will see that later too, we want to compress this file and use this information and so on. So this gets you through that discovery process, and you can read this as you get time. And like I said, don't worry about it. I'm not going to go in detail about installing dependencies because we're going to run out of time. But always read the README file, and you will actually read everything that has to do now with what is it that we found out, right? What were the observations, the requirements, and so on. So we can quickly just see here. Just try to quickly do this here. I won't spend a lot of time on the READMEs because it will take us. But then you start documenting observations, right? The field description. So we understand control area, remote unit for station, SCP. This can give us, when we do our data modeling, can give us identify what is the gate number, for example, right? So we look at all this and we document it. We document the conclusion of the things we need to do, because when the data pipeline is being implemented, that's what the code is going to do. And we define the requirements, right? We identify everything that we needed to do, how to use the CSV, how to compress the file, how to rename the columns, how to process the information. So we write all those requirements and we're ready to go, right? And now you can later on read all this information that tells you how to process the discovery process more in a process-oriented way. All right. So, but now, okay, so we have it there, and we understood some of the stuff we got to do. We understood we got to do a data pipeline. We understood it's a batch process. How do we do that? What is the next step? Well, an often overlooked and misunderstood phase here is the design and planning. and it's overlooked because a lot of this is really not focused on just data processing, but it's focused on in design and infrastructure, operational support, right? So here we're actually looking at that. This is really the foundation of the scalable solution. This is how this solution is going to run. So here's where we actually start designing the data pipeline and what technologies are we are going to use. If we build flows, what coding language are we using? Python? What are we using? What kind of data governance tools do we need, right? What kind of system architecture? Source control. Do we go with CI/CD, continuous integration, continuous delivery automation? And the answer will always be yes, right? We want to do a very mature process, not a immature process, right? So do we use Docker containers? You guys familiar with Dockers as well, right? Do we run our code in Dockers or not? And you understand, if you understand Dockers, you understand it's to control the environment so you don't have deployment issues and so on, right? How do we build the infrastructure? When we build our VMs, our data warehouse, our data lake, do we build them through click? Do we open a browser and do that? No, we don't. That is just really for practicing it or learning a technology. But to automate this process, we need to use something like Terraform, right? That is going to enable us to issue new environments, new infrastructure as we need it. As this scale up, you need to spin off more resources, more VMs, more whatever other tools you're using. And you need a repeatable, something that can repeat with the click of a button, right? And don't forget operations. How do we monitor this? How do we get notification that this thing is healthy, right? So all these things are key. System design and architecture. So now at this point, everything that you see on that GitHub project is built the way you see it here. This is a system architecture high-level diagram that tells you exactly how we build this, and everything that you see here is on that GitHub repo, right? But in system design, it tells us really how we're going to define the different technologies that we're going to use for each area of the solution, right? That includes a high-level system architecture, right? So this is very important. This is how we need to, in the design, we need to include data integration points that identify the flow and the orchestration. What storage platforms do we use? What kind of data processing tools do we need? And definitely for that, we need to arrive or define the system architecture that's going to give us all the integration points. How is the data going to flow through our system? What are the integration points? And how do we support them? Okay. And of course, using tools like Docker, Terraform, GitHub for certain things, for storing all of our codes, all of our solutions, and so on, right? Source control, key. Fundamental key here, right, is a way you can either use GitHub or whatever other system out there. But the key here is that it gives you the ability to store all of your code, so it's shareable with the team. It gives you the ability to have CI/CD pipelines to be able to deploy. So when you deploy a new VM, all the code will be deployed. When you deploy a new data lake and so on, right? If you want to create your development, your staging, your production environments, and so on, this is how you do it. Right, so with GitHub Actions, we can do the entire continuous integration, continuous delivery process, and manage our infrastructure as well as code. So one thing I notice a lot of people don't realize that this is not just for deploying your pipeline code. It's really for deploying your VMs, your data lake, your data warehouse, whatever other platform, cloud platform tools you're using. This is how you do it. You automate that process as well, okay? Docker Hub, key, right? So one of the biggest problems when we develop, right? We develop with certain dependencies in our workstation, but when we deploy, it's off. The dependencies don't exist. So Docker helps us solve that problem, right? So it helps us by creating a bubble, a self-contained environment with all of our dependencies. So we can create containers to run our code. And then those images, those containers can be pushed to a Docker Hub repo, or other cloud platforms have their different image management, container management tools. But the idea is that it's a repo for Docker images. So when you run your pipeline on a new environment, you download that image and all of it is there. Your code, your dependencies, everything is in there. And then that's how you will deploy. That's how you will automate the deployment. And of course, build with infrastructure as code, right? It's key here. We need to be able to define our Terraform files. We need to define if we're using VMs, cloud storage, data warehouse. So we need to code this. We need to create our code to be able to build what they call infrastructure as code and deploy this, right? So, and this helps us reduce manual errors. We can track infrastructure changes, and we can track the infrastructure state. What that means is if somebody makes a change, as you will see here, if somebody makes a change to the code, you run a plan, and that plan then goes through a review and approval process so you can apply it, because this is a very careful step of the process, right? This is where you're deploying and you're affecting environments. So this infrastructure life cycle is key, very, very important. All right, so my friend is telling me to move. So let's go back. All right. So this is part of your cloud infrastructure process, right? So the same thing here. You will look at the README file, and this gives you this. This is one of those areas that a lot of people will try to stay away from, because it involves a lot of things, right? So for example, I'm not going to go through the entire thing here, but this tells you, okay, we're defining our dependencies, data pipelines, orchestration. What do we need for that? We need source control. We need accounts for Docker Hub. We need accounts for whether it's a Google platform or Azure. And we need to create VM instances. So meaning is, because we're going to run our Terraform scripts, we're going to need to create account services. Service account, to be able to authenticate through the process of the infrastructure pipeline and build those and provision a VM, provision cloud storage, provision data warehouse. So this is part of that configuration where we actually get all this information, install Terraform, configure your cloud account. In this case, this is a Google Cloud account, and you can assign the roles, right? So we know, because we're going to deploy BigQuery, by the way, which is a data warehouse system, storage. Then we need to get certain permissions for this to work. So this gets you through that step, right, which is kind of painful. This is DevOps, right? So this area is mostly DevOps, but it's important for us as engineers to understand that this is really how it works, how this works, right? And this gives you through building the configuration, saving your keys, using Vault, for example, for your passwords and keys, and so on, right? So this gives you through all that. But let's look at really what's going on here. So what you will see here is, for example, we will have Docker, right? So we have a Docker file, and a Docker file is very simple. It's really, a lot of people think this is a big deal, right? Docker file is a big deal, but it's not. It's really just fetching from an image. So based on our requirement, right, our dependencies, which is Python 3.9. So we need an image for that. We need to copy our Docker requirements, right, which is really a dependency list of the things we need. We need pandas, we need prefect, we need, and so on, right? These are the dependencies. This is how you build images with Docker, right? And we run through the installation process. We build the folders in the container. We copy our flows, right? So you will see how now this step is copying, deploying code into the container, right? So this is building a container now, okay? So it's really, that's all it is. And we won't run this live because it builds an image of about 1 gig, because it's got to build all that up, and it takes time, right? So we won't do that, but just understand it's really not something magical, right? It's just very simple. When it comes to GitHub, right? GitHub Actions, basically we create this file, this YAML file, to tell GitHub when there is a commit, I push to a particular dependent. This is dependent on your design, right? So if your design can say, I want to have a gated push, right? What that means is, as I push, and there's a code change in there, I want to create a GitHub action, right? That builds the code and it repeats the process, right? So that is to make sure to automate the process that they're checking in good code, not something that's crapping out, that's not building. Because the moment it doesn't build, you can reject it, right? So, but to show you here, and this is important, the TerraBuild file here is just showing you how we could build Terraform to build infrastructure. This file here, if we check in into that branch, it will build infrastructure. But how does it know, right? How does it know to do that? So if you remember in the life cycle of Terraform, we have a code, plan, and review process. So here, basically, we're going to look at the Terraform files. So in the Terraform files, you will have something called variables. And here we're defining all the variables of the dependencies we need. What is the project name? What are we building? In what region? What kind of tier do we want this to be built on? Do we need one or two? And so on. So this is where you're defining all these variables, because then when you go to the main file, right, if you can see that, then we're saying, okay, I want to use this provider, right, which is Google, for example. It could be Azure. It could be Amazon, right, AWS. We want to build a data lake bucket, right? And we give it all the definitions of what we need. You know, we give it policies, how age files at particular days, so you can drop the files and so on. This is where we're actually now building this out in a way that is code oriented, and then we can actually just push it, right? So what we do right now is when you do Terraform, right? So you can look at this Jupyter notebook. You can just kind of look at Terraform commands, and it will tell you, you know, why do we use Terraform init, validate the plan, how do we apply the changes for deployment, and so on, right? So this gives you the process to do that, right? So here we're saying, I wanna get from my environment variables a project name and so on, and then I wanna run this Terraform plan. That what it will do, it will just basically, let me just find here new, it will just basically run and tell you that it just needs to, let me see, let me use, so for this, the kernel is that one. So if I just run this, okay, so I need to do the dependencies here, right? So, and I need to initialize Terraform. So it's gonna do and initialize the process. And then it's going to give you the state. It's going to give you all those things that you can do. And then you can look at a plan. And what I want to do is, and I hope it doesn't take too long, is that Terraform has been initialized. But remember, this is what I'm doing manually is what that GitHub build action will do, right? And it's going to do a plan. And the plan really is what it's saying is, okay, I got you. I see your files. I see what you're trying to do. I'm going to give you a plan of what you're about to do to your infrastructure, right? So he says, hey, you're about to create a BigQuery infrastructure, and you're about to create and so on. So I wanted to run it through, but the format here is not good. But it's just giving you a plan of everything here that it will do, the VMs, the data warehouse, the data lakes, and so on. And if you want to apply it, then it will push it to the data to the cloud, right? But all this really just do. All it really does, right? It just creates our infrastructure, right? So how do we use it, right? How do we use it? So let's take a look at that really quick. Okay, so always read the README. I'm going fast because there's a lot of material, but it will give you all these steps one at a time. So let's go back here. So. All right, so how do we use it, right? So we build infrastructure. We have a data lake. We we have a VM. We have a data warehouse. What do we need to do next? So we go into phase 3. So phase 3 is a data pipeline and orchestration step. This is really where it gets heavy for the data engineer, right? Because here is really where we define our workflows, we build our tasks to be executed, right? So this is where we are actually writing the code. The process is really just to start downloading the files through the APIs, right? Through a batch process or a streaming process, depending on what the requirements are. This is where we clean and format the data. This is where we focus on using Python for this or some pre-built solution. We run the pipeline. We store the data in a data lake. We deploy and we monitor and maintain. So we need to build all these things for a data pipeline, right? Not just write a particular piece of code, but understand all these needs. So usually when we implement a code-centric flow, which it means just writing a lot of code to build and supposed to using something like Azure data um, data factory, we actually write the flows, the tasks in code, and a flow will actually be the coordinator. It's the one that's saying, grab this, right? It executes step 1, 2, 3, 4. The task is that step 1, step 2. So they have a specific task: download the file, compress the file, format the file, and so on. And components are key here because these are the reusable components for us to be able to build code easier, right? So for example, we don't want to write in our pipeline code for authentication. We want to build a component for authentication. We don't want to write a way to access the data lake and upload the data. We want to write a component to do that because we're going to probably download other files. So components are key. Orchestration, right? So once you start building the flows, the components, the task, how do you run it? This is orchestration. So orchestration is really that coordination, that engine that's going to enable us to execute the task, recover, monitor, notify if there are problems with our execution, right? So key here is that we could use for orchestration many tools, right? So we could use Apache Airflow, Apache Spark for batch processing, which is a very powerful tool. Prefect, today we'll be using Prefect for this, which is code-friendly. Cloud services, right? To like Data Factory, like GCP, Cloud Data Flow, if you want to go the low-code or no-code route. And definitely GitHub and Docker to sort of automate the process, right? Because as we deploy our images, we can schedule those images to run and execute our code. So, all right, so let's look at that. That's now we're getting into more interesting stuff, right? So when you go to step 3, orchestration, same way, use the README file. But what you really want to take a look here is we're going to quickly just take a look at what's in our data lake, for example. And I hope the internet here is fast enough to see. But what you could do is, right, just run this file. Always with Jupyter Notebook, you just run from the top bottom, right? So otherwise the dependencies won't get identified. So I'm just saying for this project, for this bucket, for this container, I want to be able to query what's in there, right? So I could use CLI to query that, or I could just use the API. So we're going to use the API, right? And when we use the API, we're going to notice it's going to go through our Google Cloud, and it's going to go get to that bucket and list all the files that are there. So you see there's file, I think the latest one is from February 17, for example. And during our discovery process, we realized that this batch-oriented process releases new files every week. So the new file that we need to download would be February 24th, right? That's because it's a weekly batch. So that's the kind of understanding we need when we schedule this, when we start doing the scheduling of this, right? So, we can kind of see, right? We can kind of see so here is as opposed to looking at a CSV file, we are actually looking at a file that is in our data lake and it's downloading and it's telling us what's in there. So we can actually query our data lake now through Python, right? So because we're uploading files. And definitely you can kind of monitor some of the orchestration with this tool. So we're going to use Prefect and we can monitor some of what's going on here. But you will see in this metadata, you will see, for example, what kind of deployments are defined. And deployments are things that you schedule, right? So you will say, I have deployment that's scheduled to run every Saturday at this time for my batch process. That's what a deployment actually means. And you have some blocks, which are components to be able to build this. And we'll see in detail what that means, right? So let's take a look at this, right? So what I'm going to do, though, I'm going to start showing you the code, how this is going to run. And I'm going to run the data pipeline locally because it's going to take time. So we're going to do this in parallel. As I show you the code, this is going to process, right? So what we said here is that we probably need to download the 24th, right? So let's just execute this here. All right, because it's going to take a little bit of time to do this. All right, so, and we're going to go into flows, so into the flows folder. Well, it's already there, so let's just paste this, right? So it's going to go, okay. So this is going to say, I hope you can see, right? You can see the bottom, can you? Okay. It's going to go and say, go download February 24th, February 24th file. So this is going to go engage the pipeline. and it's going to start processing the data. So you start seeing some telemetry data. And this telemetry data is important because this is a batch execution. This is tracking the health of your pipeline, right? This is how this is being done. And the way to visualize it is, of course, we will need to go to our friendly monitor system, right? And in our monitor system, we'll be able to see how this flow is going. And I wanted to run the flow first so I can show you the code then, because that way it will end by the time we present this. So we can see there's some activity going on here, and we can actually go to the flow execution and see that there's something going on right now that's running. And we can actually look at this data pipeline and kind of see what is it doing, right? And we can see the tasks and we can see the flows, right? So we can see it's processing data live right now, okay? So this is good for the operations part of things, right? This is where your operations team is saying, hey, you're not logging anything. We need to help you. How do we help you? This is what's called site reliability team. They manage this. They track how this is happening. And you can see this is actually batching the data also. So you can see how it's writing batches of data, right? And you see this write GCS right there. What that is actually saying, I'm done with the batch of data. Everything is in the data lake. So now if we go back to that file, right? So if you notice, if you remember really quick, it had 217 was the last one, right? And so we can just run this, and it should say that we already have a new file. So at this moment, the data lake has a new file. Our data warehouse is looking at the data lake and is already tracking deltas, and we'll show you how that's done. So it already knows there's a new delta update in the data warehouse that needs to be incorporated into the data warehouse. But okay, but let's continue here really quick. Let me see if I missed something. So here you can run this to basically see what I just showed you on the browser. You can just run this, and this will give you some of what's running, right? What is the flow that's running? So this is powerful because you can automate this process, track the data, and understand the flow is running. Otherwise, something is not happening. It's not talking to the cloud, basically. That's what that's going to do. So and it just shows you the flows that are running, and it gives you telemetry on what's going on. So we're going to let that run because that's basically, we did this, right? We did this, and we did the refresh, which is what we just did there. And now we can actually go and run this. So this was 24, and we can actually see what's going on here. So let me just stop that one there because it's taking too long, right? So you can just stop it and release your resources. So this because it serializes every cell, right? So I want to use this container, right? So it's going to go get that to February 24, and this is the data we just downloaded. Right, so it's got some day 217, 218 because it's got the week, right? So it's the 24th, but it's the whole week before the 24th, those dates, right? So all right, so we see that we see this. So how do we do this? The first thing is you start building your blocks, right? Your code blocks, and the code blocks really are Docker container blocks, account blocks. So let's take a look at an account block. This takes care of authentication. This is a code block that we built, and we actually embed some of our security in there, and we can deploy this to the cloud, right? It's like similar to a Vault system, where actually all of our pipelines now can incorporate this code block into their code and say, hey, I want to authenticate. And the code block handles that. This is component-based systems, right? Where you actually building components, so you don't know, so we don't have three people building the same code, right? So this is important. The code blocks are key here, okay? The flows. Flows is where things happen. This is really where things happen, right? So for example, we look at the main file here, right? So, and you have some data here, some comments that you can look, so you can see how so it has an entry point, right? A main entry point, and that is to run it locally, like I did just now, right? Ran that locally, and it went through this, it picked up the year, the month, the day, and it went through its process. But what it actually does, it actually runs something called main flow. Right? And main flow is really the entry point that you saw on the browser. That name, what you saw on the browser, is what's called MTA batch flow. You see that name right there? right? So if you look at it here, that is the flow MTA batch flow, right? So you can see how the metadata is being collected using basically function decorators or function attributes. So this is really metadata, right? So metadata is actually being tracked that tells us what function is being called, right? So this just handles the process of saying, okay, you're giving me some parameters. Let me build the URL string to get that file. I'm going to validate if you give me a valid date. If you give me some date from 2 years ago, I'm going to reject that. So I'm going to validate the task and so on. So, but importantly here is just building those requirements and making sure. So then it's just calling this other function here, ETL web to, and you see it's another flow. So it's a subflow, right? That could be called independently based on what you're orchestrating. And its job is to actually say, okay, I'm going to go get this file. I'm going to download it, right? I'm going to do whatever I need to do, process it, compress it, but I'm going to read it. I'm going to stream it. And you saw that streaming, the steps that were being streamed. And I'm going to complete it and kick out back to the main flow. And then in the main flow, then we do some other stuff. Like, for example, let me write it to the cloud, for example. So this one now is it's a component that all it does is says, hey, if you have a file name you want me to upload to the cloud, I'm going to do that, and I'm going to use my components. I'm going to use my security component. I'm going to use my my bucket component, and it's going to move all that file there, right? So this is how that basically handles that. So, but that's the data pipeline, right? So it writes the file, processes the information, renames some fields, and so on. So it does all that. And then how do we deploy this, right? We saw it running locally. How do we run it through a container? So what we have here is you have a Docker, same way, Docker file, which is what we just saw before, right? It will copy flows and some dependencies into the container. It will build it, and then what's going to happen is if we need to run it, then we'll start looking at you can look at the README file here, and you will see the process to do this, right? So it will just explain all of this that we did here. Explain how do we use the deployment, how do we deploy, how do we push deployments to the cloud. It shows you this, right? This is the metadata, the telemetry data. It shows us how to do weekly schedule. But what's more important here, what I wanted to show you is that when we do the container, right, we write the container file with the prefect account, of course, as well. And this is how we build a container. I hope you can see that. So we log into Docker. We do the image build using our files, and we push that image to Docker Hub, right? So we're pushing that to the cloud, right? So what's going to happen is now when we do our deployment through via Dockers, we define a deployment in the cloud, and we say, hey, what are the deployments we have, which is through that prefect deployment ls, and it just enables us to run the schedule part of this. So we can say prefect deployment, run this batch with these parameters, and this is what gets scheduled, right? So when we start doing the scheduling, this is how that will be done. So what that will do, if you set up a new environment, the first thing it will do is, do I have this Docker image? And if it doesn't, it will download the Docker image, and then it will run it. Okay, so that is how you basically do this process. Okay, so but at this point, okay, we query our data lake. We know we have a new file. Everything is looking that is working, processing. We're not done, right? It's only in the data lake. It's not. We don't have it available for us to be able to do analysis on it. How do we do that? So let's go back to this. All right. So what we just did is we went into data staging, which is our pipeline grabbed the data, pushed it to a data lake, and we have that, right? So and we understand why we're using a data lake, because we knew raw data and so on, right? So it's a cheap way to store big data. But now we need to move it into analytical data. So now from the data lake, we need to move it into a SQL data warehouse, right? BigQuery in this case. So in a data warehouse is an OLAP system, right? Online analytical processing system, meaning we can query massive amounts of data using SQL, right? Which makes it powerful for us to do data analysis and visualization. So the idea is that the data lake, the data warehouse can look at the data lake as an external table. And through the data warehouse, you can query the data lake just like we did through Python and look at what's available, right? Look at what information is available there. So, but the data warehouse really, it involves two areas, right? Which is the design phase and the implementation. And design is where we're actually saying how we're going to do this, right? What data modeling we're going to use, what technologies we're going to use. Are we using SQL or do we go back to Python? We got to understand all these things. And we know in a data warehouse, just to give you the short answer is, you go SQL because it's more powerful. It will be way more powerful than doing any kind of Python, right? So in the implementation phase is where we actually execute this, right? We start doing the physical data model. We start writing our tables, our views, and so on, right? So the first thing is schema modeling, right? So you go and say, okay, what is the schema modeling? I want to use a star or snowflake schema. Sometimes you want to stay with the star schema to simplify the joins for performance and so on. It's key, very key, right? Snowflake is for other type of architectures where you actually have a lot of joins, right? Which you try to stay away from that because it will create a high cardinality dimension attributes, which may give you a lot of performance issues. So we have to understand those little details. But then the data modeling, this is where we actually now say, okay, so we got this raw data. We need to create our logical models out of that, right? So we know we got dimension tables, we got fact tables, and for that, then we need to use the data definition language in SQL to build our table. So we need to create our tables, create our views, and so on, right? So this is really the data modeling. And then, of course, optimization. Once we start building these data models, right, these physical tables, we need to identify, is it good to do data partitioning, which is really just dividing the data into particular segments, right? And data clustering. So it's an organization of data within those segments. This is important because this lowers the cost of your data warehouse. When you do an execution plan, it will just optimize query and bring the data, only the data you need without doing scans on the data warehouse. So these details here are very important. And what you see here is something called Jinja template, which is really a SQL-like embedded code that you do in your templates to build your data warehouse. And we'll look at it. So how do we build a data warehouse? We know the data is on the data lake. So the way, the lineage for this is to get that data, which is flat file as you saw it, start building our staging station, which is our logical models, our booth, our staging fact table. And then for those, we create the dimension tables for a booth, for a station, and for a fact table. So data lineage is your blueprint to execute your process, right? That's really how we build this. All right, so how do we do that? So quickly, again, you go back to your data warehouse project here. Quickly, you can go to BigQuery really quick, open this notebook, and this just will tell you, for example, how to run this and connect to BigQuery, right? So same, just define a connection to the data warehouse and start running some SQL. So here you can start running SQL, right? This is the way you run SQL. And this is, remember, this is through the API, right? If you connect to the BigQuery using the studio, you use all SQL like query string, but this is through the API. So keep that in mind, right? So now we can see what data is out there, right? We can see all these things. We can see the tables that are defined in our data warehouse. We can see that. We can print the number of records that we see there. And we can do some data analysis, right? We can just kind of see and kind of look at, let's look at this one. This is kind of important. So what's the max date we have here? So the max date we have here, right, hopefully is 16. And we import it to the 24th. So now we have a delta that's pending, right? So we know that because we did this manually. So you can run this. So what we do is, and I'm just going to run this process now and let it run in parallel. So this just gives you queries of how to use Python to do certain queries, right? So when we go to this project here, there's another one called data modeling. And data modeling gives you all the stuff where that I just talked about, which is the lineage. How are we going to run this, right? And how do you set up your dependencies and so on, right? But what's key here is that because we have a delta change, we can run this step here. What this is going to do is really going to go to the data lake and process that information and see if there are additional stations in that file. Hopefully they're not, because stations don't get built every day. But this is actually going and say, are there any delta changes? And this is running live from the data lake to the data warehouse, right? So it's actually saying, okay, let me just take a look and see, and let me process what's going on here. Right, and it's gonna say finish. I finished successfully, and what did I do? It says I merged 0 rows, but I found a file with 171 megs of data. But it found no new stations, right? It found no new stations. That's good. So okay, so this is the process that gets automated. Of course, I'm doing it manually, but it gets automated, right? You do the same thing for the booth, and so on, and then you do it. And then let's import that new file. So let's run this process here. And this is really now what this process is going to do, and I'll show you how these models look like, is really grabbing that data and saying, hey, what are the delta changes? And all it is doing behind the scenes is doing a SQL merge, right? It's creating temporary tables, it's querying against the fact table, and it's saying, do I have this new record? And how does it know if I have this new record? Because there is a surrogate key that's based on a particular criteria, which is station name, day and time, and so on. That gives you uniqueness for that. So if you notice, it went through and it ran, and think about it. How long did that pipeline take to upload data into a data lake, right? Think about this one. This one, you went split seconds. This, in 7 seconds, merged 253,000 rows. 253,000. You will never do this on a Python data pipeline. Never be able to do this. So you got to use the power of the SQL or the SQL engine at this point to do massive batch updates or inserts in this case. And it processes that amount of data so quickly in 7 seconds. And what you want to do to follow this, since we're running out of time, is that you're going to look at the models folder. That's the key. You're going to look at the staging and the core models, and there is your SQL. This is how we build this. If you remember that lineage just started with staging, station, right? This is the code to build that lineage, right? And it materializes the data as a view in the data warehouse, right? And off of this view, we build materialize an incremental table called dimension station. And what that really means is it's going to build the table itself, and it's going to be able to support logic that when we run this process, it's going to do a merge, a SQL merge, to incorporate new data. And when it comes to the fact table, the same way, we optimize it. We tell it what type of partitioning and clustering to use. We do also incremental strategy, which is merge the new records, and it has some logic to figure that out. And behind the scenes, it does its magic, temporary tables and all these things. And this gets you the data to basically the data warehouse. And if you notice now, once we go back, and I know we ran out of time, we can run the SQL query, and you will see that now we got new data here, right? I think it was 216 or something. And this new data now. So the data is available now. So quickly, as we just quickly do this, just remember now the next step is visualization. So how do you visualize this data, right? How do you now take it out away from the data warehouse and you visualize it? Well, simply speaking, and I'll just show you really quick. You can do Looker, this is the visualization report that you get out of this, right? This connects to the data warehouse. This grabs your data modeling, which is your dimension tables, your fact tables, and it just handles the data for you. And if you're noticing, a lot of the code that we did some special time slots that we did code. So for there's no out of the box time slot. So you need to do a little bit of logic for that. So what you will do in this case is with tools like Looker, Power BI, and so on, you will create calculator measures, right? And you will see that these are just functions that will just do the magic for you, right? It will just map it. And remember how we did it in Python, right? When Python, and when we started the discovery process, we did that, and this gives you that, right? So this is actually how you connect to the data warehouse, build your dashboard, do all these things, and basically visualize. And what's going to enable these people to be able to say, hey, at a particular time frame for this station here, right, I want to be able to look at the data, how many people are there. Is it worth it to create a campaign around that time for this station? And that's how they're going to use this to be able to make those business decisions, right? So really quick. So this is just the last part was really visualization. There is a data analysis Jupyter notebook file that goes through that, or how to break this down, how to do the code-centric. So there is a whole code-centric dashboard that's created that you can take a look. There is the low-code dashboard and design principles of how do you do visualization, right? Because everything has to have some kind of design principles. This takes us to that line that I show you, that code that I show you, and basically a lot of information. And I think we barely made it, right? So guys, a lot of this stuff, this is very quick, very compact, but a lot of this expanded on the GitHub repo. There is this book here that I wrote based on all this information I share with you and more. You can take a look at that. You can find me on Twitter. You can find me on LinkedIn. I'll be more than happy to connect with you guys. So take a picture if you need to. I'll be sending this information. The video, we're recording the video. So follow me there because I'll be posting when that video is available. Follow the GitHub repo, please. And keep, track it because we're going to keep pushing more information. Also, there's AI stuff that we do. So just please follow us and we appreciate it. But thank you. Thank you, everyone, for being here.
Is the book conceptual or do you go through the stuff in your shape?
This book has both. It goes through the concepts, so the slides, for example, but in deeper detail. Why do we do this? And then it goes through the hands-on code. And all that code that you will see there is on GitHub repo.
And then you said this was on YouTube. What's the YouTube channel?
I'll forward the YouTube channel to you. I can't really remember. But if you look for OCKARY, you see that OCKARY? Just look for that. Or if you go to my blog really quick, you will have basically you will have videos embedded in there as well, which are part of that YouTube channel. But I go more in detail about this stuff, right? Because there's a lot to cover. You have the link to the book there. You have the also AI stuff. So this is more the data modeling that I was talking about, the lineage and all those things, right? This is a deeper dive into lineage. It's specifically just for the data warehouse. And you have the video and you have all the slides that are deeper into why do we do what we do, right? The lineage, all of this is really deeper into that. But definitely the book is more of an expanded version of this. Thank you, everyone. I really appreciate you joining me today, and have a good day, okay?
One last question.
Yes, sir.
You set all this up across all these different tools. Do you have an idea of how much it would cost to maybe run it for a week?
Right. So remember, all of this depends also on volume, right? So there's a core basic cost of resources. Like a VM will have, I don't know, like $30, whatever. But then volume, what is your volume? So you can do some statistics on your volume. Like we see right now, is maybe it was 180 megabytes of a file, for example, and it's a weekly batch. How much is that going to cost you? And then the hosting of data. So how many gigs of data you're going to be, or terabytes of data. So it's a lot of stuff, right? It's a lot of stuff.
When you run it, though, is there like a ballpark? Like, could you set up this project with?
Right now, right now, everything that I ran, I use the data lake, the data warehouse, everything zero cost.
Oh, yeah? Because it's so small.
It's small.
You're going to be in Miami, right?
I'm sorry?
SQL Saturday, Miami?
Yeah.
I
No,
might try to build it before then. Are you not going to that one?
no, I'm not going to that.
I saw your session, so I was hoping to build it and take a break.
When is the SQL Saturday in Miami?
It's in a month, I think.
Okay.
They just hit the schedule again, but I had seen your session there.
So by the way, this is streaming live